Solve the matrix equation AX equals B for X. Well, we need to remember that when we deal with this sort of matrix equation AX equals B, we have to go ahead and multiply both sides of the equation on the left-hand side by A inverse. The reason that we do that is because A inverse times A will yield the identity matrix, which when multiplied by X will simply be X, because the identity matrix multiplied by anything is that particular matrix. And that means that this will be equal to A inverse times B, yielding the fact that X will be equal to A inverse times B. Now obviously we need to make sure that there are some assumptions that are in place that hold true throughout this process. Remember that A is a 3 by 3 matrix, and B in this case is a 3 by 1 matrix, which means that if A is a 3 by 3 matrix, and we'll go ahead and write this out as such. So A is 3 by 3, and that's going to be multiplied by some X, and that's going to be equal to matrix B, which in this case is a 3 by 1 matrix. We know from our definition of matrices and matrix multiplication that this right here, this number, is going to be the number of rows in matrix A, and we know that this will be the number of columns in matrix X. Which means that if we go ahead and write this out as such, we know that this must be a by 1 matrix. We still are unsure of what's going to go in this place, but in order for two matrices to be multiplied together, we know from our definition that these two numbers must be the same. Ergo, this will be a 3 by 1 matrix. So that means that we can transform matrix X into a variable matrix of 3 rows and 1 column. So let's write this out. We're going to have matrix A times matrix X will be equal to matrix B. So matrix A, we start with the fact that we know it is a 3 by 3 matrix. And we're going to write the matrix out. And we're going to multiply that by matrix X, which we know must be a 3 by 1 matrix. And since it's a variable matrix, it will represent X, Y, and Z. And that will be equal to our matrix B, which we know is a 3 by 1 matrix also. And that is going to be this matrix right here. Now, we're going to use the matrix calculator that we've discussed in class in order to solve this. When I go ahead and write this out as such, I still don't know what matrix X is. And so what I need to do when using the matrix calculator, I've gone ahead and listed the length that we're using, and in order to input this properly, you will enter, in fact, the matrices in a certain order. So let's go ahead and bring in the actual web page that contains the matrix calculator. And we will go ahead and input. Now, notice that I am left clicking in the input field here. And when I say entering in the input field, we're talking about right here. And the directions for inputting a matrix is contained very clearly in this area. So what we're going to do is enter our first matrix, which is a 3x3 matrix. We are going to enter each row separated by columns, or each entry in each row will be separated by commas, and then we'll separate the rows with colons. So the first entry will be 1, -2, -3. Then I'm going to put in a colon to separate the rows, and I will have -1, 4, 6. And then I will use another colon to separate the rows and have 1, -1, -2. Once I've done that, I will go ahead and click the Enter key, or the Enter tab right here. And notice that my matrix is now showing up right here. And now what I'm going to do is go ahead and left click the inverse right here. I will left click inverse, and this right here is the inverse matrix A inverse. The next thing that I need to do is enter matrix B. Now we know what matrix B is, and so we'll go ahead and enter that. And so we're going to clear the input window, place the cursor back in the input window, and simply go ahead and type in 7:4:5. I will press enter, and you'll notice that we now have matrix B in the output window. The next thing that I'm going to do is just left click multiply, and this gives me the answer. And this is going to be what x is equal to: 18, -17, 15. So the matrix x, y, z is equal to 18, -17, and 15. And then we can individually write that out if needed. X equals 18, y equals -17, z is equal to 15. And I could just as easily say that x is equal to this.